Alright, so the purpose of this lesson is for me to share with you how to find the standard deviation of a set of data by hand. Realistically, most of these problems you're going to do on the calculator, and I'll be showing that in one of the later videos, I think tonight. But occasionally you need to know how to do this by hand. Some of you may, have looked at it in the formula book, and if you look in the formula book, they do give you a formula for it. They tell you that the standard deviation, the symbol they use is often lowercase sigma, is the square root of the sum from I equals 1 to k of f sub I times x sub I minus mu squared all over n. And they don't tell you this, but mu is the mean. And so suddenly one thing about this line makes sense. You're like, yay, I know what the mean is. What the heck is this? I'm actually going to, what I'm going to show you is how to do this, but I'm going to give you sort of a 5-step process for how to do this. I'm going to sort of attempt to give the 30-second version of it right here, just so you understand this formula. What this formula says is it says you need to take the sum of something. And I'm going to ignore the frequency for just a minute. We need to take the sum of this thing. xi is the data point, m is the mean. So what they want you to do is they want you to take the data point and subtract the mean, and then square it. They want you to add up all of those, and then divide by n. So divide by the number of terms that you had, and then take the square root of it. That's what that formula means. And if you want that to mean something, you might come back and look at that formula again after we go through the steps on the next page. I think after we do an example of this, you'll find computing the standard deviation is a little bit tedious, but it's not actually hard. So let me go through the steps and then our example. So here are these steps to find the standard deviation. First step, you have to compute the mean of the data. So if you're doing this by hand, add up all the data, divide by the number of terms that you have. Okay. Second step, subtract the mean from each of those data points. Right? So you had your data points, subtract the mean from each of them. Step 3, you're going to square each of the results you got in step 2, which means if any of them were negative, it's okay because you're squaring them. Right? Step 4, find the mean of all the things you just found in part 3. So in part 3, you just squared a bunch of things. In part 4, take the mean again. Add up all of those squares and divide by how many there were. The result you find in step 4 is something called the variance. Right? So that's the variance. If the problem asks you for the variance, it basically means do this process and don't do the last step. Right? Step 5, and I even say this here, if you stop at step 4, you found the variance. To find the standard deviation, you just take the square root of the variance, of the thing you found in step 4. So standard deviation equals the square root of variance. Which, goes the other way around. If you need to find the variance, you can square the standard deviation. Occasionally they'll ask about different things, so just be prepared for that. So now let's get into the one example that we have. I almost finished that before the bell rang. Oh well, I won't take it out this time. We'll just enjoy the laugh. So let's get to that example. Alright, so given that the bell just rang right in the middle of that one, I figure I have about 3.5 minutes to get through this example. So we'll find out whether or not we can make it. So find the standard deviation of this set of data. Right, so we said previously that step number 1 was going to be to find the mean. Right, so for the mean, we do 1 plus 2 plus 3 plus 10 divided by 4. That ends up being 4. Right? Step 2 is where we do our data points minus the mean. Right? So I'm supposed to do 1 minus 4, that's negative 3. I'm supposed to do 2 minus 4, that's negative 2. I'm supposed to do 3 minus 4, that's negative 1. And I'm supposed to do 10 minus 4, which is 6. Right? Then I'm actually going to do step 3 sideways. Right? Step 3 is where we're supposed to square those results. Right? So the negative 3 becomes 9. The negative 2 becomes 4. The negative 1 becomes 1. And the 6 becomes 36. Okay? Then step 4, I'm supposed to take the mean of step 3 results. Right? So that means I'm supposed to do 9 plus 4 plus 1 plus 36 all over 4. So let's see here. These two things together make 10. These ones make 40. So I'm looking at 50 over 4, which reduces to 25 over 2. This is the variance. I know the question didn't ask for the variance, but if it had, there it is, right? That is the variance. And then our final step, step 5, we remember that the standard deviation is equal to the square root of the variance. So that means our standard deviation, our lowercase sigma, is going to be the square root of 25 over 2, which we could reduce to 5 over root 2. If you wanted to, you could make that 5 root 2 over 2. Any of those would be acceptable. This is the standard deviation for that set of data. I'll make a brief mention of what this means. That probably means I'm going to go over my 3.5 minutes. We'll get another bell here, but we'll see what happens. This number, if you use a calculator, is 3.54. What it means is, and this is, what I'm about to say is not strictly speaking correct, but it's close. What that means is, it sort of means, our data was 1, 2, 3, 10. My mean was 4. It sort of means that on average, these data points here are about 3.54 away from the mean. Again, that's not exactly what it means, but it sort of gives you a sense for how spread out your data is. If the standard deviation is higher, it means that on average your scores are far apart. If your standard deviation is small, it means that on average your scores are close together, right? So to reiterate, and I think I just said this, but to reiterate, if you have data that's closely packed together, like if you've got, let's say for instance you've got, there was some quiz where the scores were, 15, 15, 16, 16, 17, 17, 17, 17, 18, 20, I would expect my standard deviation to be small. Right? The average of this data here is, probably 17-ish, right? That's going to be the average. My standard deviation is small because on average the scores are close to one another here, right? If we had some other quiz where, there was a 1 and a 2 and some 3s, and then we jump up to a 7 and a 10 and a 15 and then some 17s and a 20. In this case, you can see that the data is not close together. The data is spread out. The average here is probably somewhere, around 10 or so, and on average these scores are all far apart from one another. Because of that, we suspect that the standard deviation is probably going to be relatively large because the data is spread out. So the title for this lesson was Measurements of Spread, and then Standard Deviation. Standard deviation is one of the ways that we measure how spread out the data is. If the standard deviation is small, it means it's not spread out. If the standard deviation is large, it means the data is spread out. So at the end of this video, all I sort of really showed you was this idea of how do we find standard deviation by hand. We're going to look at a few more measures of spread, and then after that we'll move on and we'll look at this stuff on the calculator. So I'll see you there.